Good day, class. Now let us analyze simple AC circuit calculation. A question says that a series circuit consisting of a 100 ohm resistor, a coil of 0.1 Henry inductance, and a 20 microfarad capacitor is connected across a 110 volt 60 hertz power source. The first question here, we are to draw the circuit diagram of the arrangement and then calculate the inductive resistance, the capacitive resistance, impedance of the circuit, current in the circuit, voltage drop across the resistor, capacitor, and inductor. We are to calculate the power factor, the power loss, and phase angle. When you look at this question is on RLC circuit. And a simple AC circuit is always a series circuit. So let us draw the diagram. That is the first question there. So it's a series circuit diagram. We have it this way. We have it like this. So we have it in this format. This is the resistor. This is the inductance. Sorry, this is the inductor. This is the capacitor. The resistance of the circuit is 100 ohm. The inductance of the circuit is 0.1 Henry. And the capacitance of the circuit is 20 microfarad. Now, this is the symbol for AC, that is alternating current. The current that will be flowing through it, we call it root mean square current. Then the voltage that will be drop across it is root mean square voltage, and that is what is given to us as 110 volt. And we are given the frequency of alternation F, which is equal to 60 hertz. Then this is the circuit diagram. The second question there said that we should calculate inductive reactance or reactance of inductor. So inductive reactance X subscript L is given by omega L, and omega is 2 pi F, then L. Now when we substitute our value here, we have 2 pi times 60 times 0.1. When we evaluate this, we are going to get 37.7 ohm. Then the third question says that we should calculate the capacitive reactance or reactance of the capacitor. Capacitive reactance, which is X subscript C, which is 1 over omega C, which will be 1 over 2 pi FC. When we substitute our value, we have 1 over 2 pi, F is 60. Our C is the capacitance of the capacitor, which is 20 microfarad, which is 20 micro means 10 raised to power minus 6. Then from here, we take this 10 raised to power minus 6 up. It will now be 10 raised to power positive 6 over 2 pi times 60 times 20. When we evaluate this one, we are going to have 132.63 ohm. Then the fourth question here, we are to calculate the impedance in the circuit. Impedance in the circuit. We use Z to represent impedance and is given by the square root of R square plus, open a bracket, we have XL minus XC, close the bracket, square. This is the formula for it. Then we have Z is equal to the square root of R is 100, this will be 100 square, plus, open a bracket, XL is 37.7 minus XC is 132.63, close the bracket, then we'll square it. When we evaluate this one, we're going to have the square root of 100 square will be 10,000. Then plus, when we evaluate this one will give us 9011.7. Then by the time we add it together and take the square root, we are going to have 137.9 ohm. Then the next question here, we have to calculate the current in the circuit. Current in the circuit. Which is the same thing as I root mean square, current. Then from Ohm's law, you know that I is equal to V over R. But here in this circuit, the overall resistance to the flow of AC in the circuit is the impedance. So we replace R with the impedance. Then our V is the root mean square voltage, which is given as 110 volt. Then the impedance is 137.9. By the time we evaluate this, the current will be 0.8 ampere. Then the next part of it, here we are to calculate the voltage across the resistor, across the inductor, and across the capacitor. Now let us look at, which is question number 6. Voltage across the resistor, VR, is given by IR according to Ohm's law, and this I is 0.8 and the arrow is 100, and this gives 80 volt. Then voltage across the inductor, which is V subscript L, is given by IXL, and I is 0.8 and XL, we calculated it to be 37.7. When we multiply this one, this will give us 30.16 volt. Then voltage across the capacitor, VC, is equal to IXC, which is equal to 0.8 multiplied by 132.63, and this gives 106.1 volt. Now we can check whether these voltages that we calculated is correct. How? Now let us check. How do we check? You know, from our impedance, Z, let's go back there, is equal to the square root of R square plus, open a bracket, XL minus XC all square. Now we can translate this one to voltage. Now this is the overall opposition to the flow of AC in the circuit. Then the overall voltage in the circuit is V root mean square, then which is equal to the square root of, here we have voltage across the resistor square plus, open the bracket, here it will be voltage across the inductor minus here will be voltage across the capacitor, then square it. Now let us put their value and see whether it will be equal to this. Remember, V root mean square is equal to 110 volt. So let us verify whether it will be equal to it. Then is equal to the square root of voltage across the resistor. We calculated it to be 80. Then we square it plus voltage across the inductor. We calculated it to be 30.16 minus voltage drop across the capacitor. We calculated it to be 106.1. Then we square it. When we do this, we have V root mean square is equal to the square root of 12166.88. When we carry out this calculation, when we take the square root of this, we find out that V is equal to 110 volt, and that's what is given to us in the circuit, which is correct. Now, the next question here is we are to calculate the power factor. Power factor, which is given by cos angle phi, and which is normally given as R over Z. And our R is 100, our Z is 137.9, and this gives 0.725. Then again, the next question we are to calculate here, we are to calculate the power loss. We have IV. So we have to calculate the power loss. And this power loss, P loss, is given as IV cos phi. And our I is 0.8. Our V is the V root mean square in the circuit, which is 110, times cos phi is the power factor, which is 0.725. 0.725. When we evaluate this, we are going to get 63.8 watt as the power loss. Then the last part of it is we are to calculate the phase angle. We are to calculate the phase angle. The phase angle. Now, if the phase angle is given as theta, then tan theta is given as XL minus XC over R. Or if it is the voltage you want to use, we use VL minus VC over VR. Now let us use this one. We have tan theta is equal to XL is equal to 37.7 minus XC is 132.63 over R. R is 100, and this gives minus 0.9493. That is, tan theta is equal to minus 0.9493. Then our theta here will be tan inverse of minus 0.9493. When we press our calculator, we are going to get theta to be equal to minus 43.5 degrees. Now the question here is, are we going to leave our answer here like this? No, because it is minus, we need to reinterpret it. Now, for this theta to be minus, that means when we remember our quadrant, in this first quadrant, you know that all the sines, cosine, and tangent, all of them are positive. Therefore, this theta cannot be in first quadrant. Then in this second quadrant, it's only sine that is positive. Both cosine and tan are negative, and since this theta is negative, that means theta can be in this quadrant. Second quadrant is 180 minus theta. We are coming back to it. Then in this third quadrant, it is tan that is positive. For that reason, tan cannot be in this third quadrant. Then in the fourth quadrant, it's only cosine that is positive. Also, tan can be in this fourth quadrant. And in this fourth quadrant, the description of the angle here is 360 minus theta. Now let's look at it. So we say theta in second quadrant, then we have 180 minus theta. This will be equal to 180 minus 43.5. And when we evaluate this one, this will give us 136.5 degree. You find out that when you press tan of 136.5 degree and tan of minus 43.5, they will be the same. It will give you this value. Now let us look at theta in fourth quadrant. In that case, we have 360 minus theta. This will be 360 minus 43.5, and this gives 316.5 degree. So when you press tan 316.5 degree and you press tan minus 43.5, it will give you the same answer as minus 0.9493. Thank you very much for listening. So be expecting another tutorial questions.